Hello and welcome to Techcyte's 13th episode of Pioneers in Digital Diagnostics. Today's webinar is expanding the Techcyte Parasitology Suite, introducing wet mount iodine screening. We're delighted to have you today. We encourage you to put your comments, questions in the chat, and we will address those at the end with our Q&A. I am Jacob Hicks, and I'm delighted today to be joined by our VP of Marketing, Troy Bankhead, who's based in Luxembourg, and John Walker, our Senior Systems Engineer, who has been part of the journey with our AI and workflow tests for parasitology applications. John was also one of the co-authors in the Journal of Clinical Microbiology article years ago when we released our first solution within the Parasitology Suite. Today, we'll share a bit about who Techcyte is for some of our new viewers. We'll also talk about current wet mount practices for ovum parasite screening with the fecal smear. We'll also talk about our specific solution for this application. We are especially excited about a live demo. You'll get to see Techcyte software in action. We'll have John walk through that on several use cases of how Techcyte can be a very effective and efficient tool to screen your O&P samples, particularly negatives. We especially are also looking forward to sharing some high-level study results from a study conducted by ARUP Laboratories. It was a very robust study. ARUP Laboratories is the largest nonprofit clinical and academic reference laboratory in the United States. And lastly, we'll definitely devote some time to Q&A. So a bit about Techcyte. Techcyte was founded a dozen years ago. We were actually originally a technology transfer out of the University of Utah and ARUP Laboratories. We've built an AI and workflow software platform to automate and digitize diagnostics tied to microscopy across the medical, veterinary, and environmental laboratory space. And we've done more than 5 million AI diagnoses, AI clinical results for patient and animal and environmental health. In building a platform that helps laboratories do more with especially the shortage of folks rising up into the skilled microscopy ranks, we believe our platform really enables the best of both worlds. Skilled laboratory professionals across anatomic and clinical pathology applications, coupled with our AI and workflow software platform, really does result in time savings and efficiency gains designed to improve patient care. Our mission in building this platform is to positively impact the health of humans, animals, and the environment through the use of AI and by becoming the preferred digital diagnostics and digital pathology platform. When we talk about our platform, we have applications across anatomic and clinical pathology. Today, you'll hear more about our applications within the microbiology and parasitology space, but we do have them across histology and other applications across heme, tissue, liquid, smearable, cellular sample types across all those various disciplines. Techcyte has solutions for. Our platform is a lot more than just a viewer or storage or a place for folks to maybe do a digital review. It has custom workflow and AI. It has in-house AI and third-party AI integrations. We enable scalable reporting and LIS integration. We've done that now in massive scale globally through the 6 inhabited continents. And we understand what it takes to help you actually gain efficiencies by moving from a microscopy manual glass workflow to a digital workflow. With that brief background about Techcyte itself, I'll turn the time to Troy, who will dive into our exciting product release.
Thanks, Jacob. Appreciate that. Today in microbiology labs, there are 3 main methods for screening parasitology. The first is in microscopy, which has the advantage of being able to detect anything that the operator sees. But depending on the operator, they can be less sensitive. They're definitely time intensive, and they're subject to labor shortages. You also have multiplex PCR, which has high sensitivity, but only detects the pathogens that happen to be included in the assay that you're using. They're also expensive, not always included in reimbursement schedules, and they're limited, of course, to the targets that are in the kit. And then you have antigens, which those tests are quick and inexpensive, but they only detect pathogens and have limited targets in them. Our answer to this is the Fusion Parasitology Suite. Now, we do have already two components to this. The first being our trichrome solution, the second being modified acid fast. Trichrome being the primary stain used in the US. And today we are proud to be introducing to you the third component of our suite, which is wet mount iodine. In describing to you our system, there are 4 different workflow steps. The first is in slide creation. And to illustrate this, I'd like to just play for you a short video that goes over some of the steps.
A technician gathers the necessary supplies, including glass slides, cover slips, micropipettes, mounting media, and stool samples. The technician vortexes the mounting media and stool sample for 30 seconds to ensure homogeneity. Using a micropipette, they draw up 15 microliters of mounting media and carefully dispense it onto the slide. Using the same micropipette, they draw 15 microliters of the stool sample and mix it with the mounting media on the slide. They place a cover slip on the edge of the slide, positioning it so that the mounting media and stool mixture touch it before slowly lowering the cover slip down onto the slide.
So I'm sure you noticed in that short little clip that the process for slide preparation using our system is standard in the sense that all of the vortexing and the isolation of the sample follows industry best practices. Once the slides have been prepared, they are then scanned using one of Techcyte's approved scanners. Now, we have currently validated 3 different manufacturers, the Promana Spectral M, Pro, and their HT line, which includes the 2 and the 4. We've also validated the Grunium Ocus 40 and the Hamamatsu S360 and the S20. And when we say validating scanners, there are many steps involved in this. It's not just a question of purchasing a scanner, hooking it up, and having it go. With liquid-based samples, in fact, if you were fortunate enough to view one of our previous webinar episodes last year, we had an episode on the intricacies and difficulties in scanning sparse and liquid-based samples, where we go over in more detail some of these points. But these developments include developing custom scan profiles where we work with the manufacturers to make it a plug-and-play operation and ensure that we get AI-worthy images out of the scanners that we validate. And one of these intricacies or challenges is in the fact that when dealing with fecal samples, it's a very viscous and thick solution compared to others such as blood smears that are pretty much monolayer. And you also get movement with the slides. And most importantly, there is a very short slide viability time that must be taken into consideration. And so once these samples are scanned in, they are immediately sent up to our cloud. Our service is based in the cloud, and the AI performs the analysis and then presents the results to the end user. And that's where we get to our interface. John, in just a moment, is going to walk you through a demo, so I won't go over in too much detail here, but our system it complements the trichrome and MAF tests. The interface will look similar, and what it does is enables operators to very quickly, rather than spending their time hunting for these organisms in samples, we present the organisms of interest, and that allows them to very quickly go through and screen the overwhelming negative slides in a daily workflow, as well as better being able to detect the positive ones. You can see the full list here of the parasites and organisms that we detect. And of course, a full list is also on our website. And because this is a companion product to trichrome and MAF, our interface allows for multi-scan management. And again, John will show you this, but it does allow you to, within the same case, use both, for example, trichrome and iodine to complete your analysis on any given patient. And so without any further ado, I'd like to turn the stage over to John for a demo.
Troy, if I could jump in, would you mind showing, I think we have a quick video for our users around the loading a scanner and that step. I think that might be helpful.
Absolutely right. Yeah, I'll play that now.
Technician loads the cover-slipped slides into a Techcyte validated scanner. The slides are scanned and automatically uploaded to the Techcyte platform for AI analysis.
There you go. Short and quick. Appreciate that, Jacob. That just goes over the process for scanning the slides into the scanner. So, John, take it away for a demo.
Thank you, Troy. All right, let's share a screen. Welcome, everybody. I look forward to showing you the actual use of Techcyte with our wet mount product. I'm going to show this to you in two parts. The first, I'm going to show you with some test cases that have only a wet mount, which would simulate for laboratories that are not using trichrome or other alternative stains in addition. And at the end, I will show you with some combined trichrome and wet mount for that review process. The first step here, I skipped the login process. I'm looking there is, as a technologist, I'd come in here and say, okay, there is work to do. So I'm going to go ahead and assign these to myself. This does two things. The first it does is helps me build a work queue of work for myself to do. The second thing it does is prevent any colleagues from trying to review the same work that I have in progress. So now I've switched to an assign to me filter, and I'll start with the first test case. So before I dive into that, I do want to show you a couple of things about the interface. The first I want to show you is that if you were running this as a technologist, you would be generally running this as where you maximize a lot more of the sample area for your screen. And, it'd be running on a good size monitor. But for the purpose of this demo, I'm going to make things a bit bigger so we can so you can see the wordage. To orient you to this interface, you can see here, these are organism candidates of interest that the AI has identified. This is an optional overview of the scan area, which can also be used for zooming. I'll show that. And then along this side are the listed organisms that it found, which is how you confirm the presence of the organism. And lastly, at the bottom here, we have the assessment drawer, which is used to navigate my work queue. It is used to add any notes relevant to the diagnosis. And for special situations, like if the scan is bad, you can mark it as an invalid image, or if someone wants a consult, either from a medical director or from a senior colleague, they can optionally request a consult instead of giving a review. So starting on our review of this case, looking at these, I am not seeing any organisms that look positive to me. The AI does identify, it is visually based, and so it will identify things that look like things. You can see that this artifact looks like an E. coli, Entamoeba coli. So you can see that it's got about the right size, and there is some debris that looks a lot like a bullseye nucleus. But that is not an organism, and I'm going to reject that. So I'm on into my miscellaneous protozoan class. Although this is a wet mount, which primarily targets the cyst form of these protozoan organisms, you can see that there are a number of classes that are covered. I don't know if you can read those, but for example, this class combines Dientamoeba fragilis, Inana, Iodamoeba, Entamoeba hartmanni, and Calamastic trophozoites. Having completed that review and deciding I don't see any valid parasites, my last step here is I'm going to check through these overview images. These are imitating the field of view of a 100x oil microscope, and I'm checking these to make sure the majority of these have good focus. Since I'm calling this negative, if I had a bad scan, I would not want to trust it. I would want to manually review it. So having reviewed all of these, I'm going to say there's nothing here that convinces me. I'm going to save. It's going to ask me, because it's a negative, it's going to ask me to confirm. This is an optional configuration component. And that's saved. I'm on to the next test sample. Again, doing the same process. I'm going to start at the top with these different classes. I don't trust those blasto. None of those are Giardia. That is not an Entamoeba, that artifact. This is an interesting mimic, but it is not a Blantoides. And in zooming in and taking a look at it, I can see that that's the case. Finally, because it's negative, I am going to check my prevalence regions to make sure the majority of them look good. Can also zoom out and see the whole scan image to make sure the majority of it is covered. And we're good. So I'm on to the next one. This is in practice how fast the reviews are by the technologists actually using the system. All right, on to our next. So starting at the top, right? For protozoans with the blasto, no. A couple of interesting mimics, but no, those are not entamoeba. And downstream, I can see this definitely looks like a helminth worm egg, a Clonorchus. And you can see I've got several good examples here. This is obviously positive for this organism. I'm going to click on that. I don't need to add any notes. Save and next. So now this is a positive read. Positive does not mean that it is finalized. It does mean that that is a sample that should be manually reviewed on the microscope to confirm that organism, to confirm prevalence, and to verify that there are no other companion organisms in the sample. All right, on to our next one. You know, again, as a technologist uses our system, we found that they are very rapidly able to accelerate the amount of time it takes for them to review a sample. You can see here, I'm looking and I can see the telltale signs of iodine with these large vacuoles. So we're definitely going to mark that positive. We'll continue down to a miscellaneous. Some of these are going to be iodine, but I've sort of already made up my mind about that. Because this is positive, I do not need to review the prevalence regions. Even if half the scan were bad, if you've spotted an organism, it's time to manually review that sample. This last one here that I wanted to show you of the single wet mounts is you say, well, you've talked about not trusting the scan. You can see from this overview image that this is probably a high debris content sample, and it dried out before we could get a good scan from it. We developed a proprietary mounting media along with ARUP that preserves the samples for longer than is typically seen with wet mounts. But if there's large debris or something else that could hold up the cover slip, the sample will start drying almost immediately. So looking at this sample, I would say, well, even though I would read this as a negative, because remember, if there's positive organisms there, it's still positive. But reading it as a negative, looking at this overview image, I'm going to say, you know what, this is an invalid image. And that's going to be my review, which is going to add this to the list of items that need to be reviewed for manually on a microscope because the scan failed. All right, so that was the single scan type review process. With the addition of the trichrome, now the process adds, you can see now at the bottom here, we've got both scan types available, and I'm free to toggle between these two as I'm trying to make my assessment. Generally, they're done one at a time with confirmation from the other. So I'm going to return to the trichrome here and start with that. So I'm following essentially the same process. None of these are convincing to be a parasite organism. Looking at the combination of the overview image and my prevalence regions, I can say that is good. It's a negative. Looking at my wet mount, doing the same process. I'm not seeing anything here that I didn't see in the trichrome. There are no extra organisms that the AI identified as candidates. So same process. I review my prevalence regions and call that done. Now here you'll notice it took me back to the trichrome because it said, well, my friend, you forgot to review the trichrome and give your assessment for that. So before taking me on to the next test case, it took me back to the trichrome. I've already reviewed that. I'm going to confirm it as a negative. All right, our next one here, we got another pair. Starting at the top with the Giardia. Not convinced by that. There are a couple of interesting features, but there's only one of them, and it's not 100%. Looking at our possible defrag or enana, none of those are convincing. not the Hartmanni. Oh, but now getting down into amoeba species, which includes E. coli, Histolytica dispar, and Polytechnicae. You can see that I am, I jumped to one of the options, which is to jump to a full screen zoom to examine the organism. But returning to my review screen, using the side magnifier, I can see that I have my telltale bullseye nucleus. Size and shape are as expected. I can confirm that by measuring. So that's within the size range that I would expect for one of the entamoeba species. You can see it edited over there. I'm going to confirm entamoeba is positive. See a few white blood cells here. Those may or may not be reportable depending upon your lab. Don't need to look at the prevalence. I've already decided this is positive. Going to my wet mount, starting at the top with my protozoan classes, I really don't expect to find any surprises. And lo and behold, just like with the wet mount, there are entamoeba here. We do look for both the cysts and the trophs in the wet mount for the entamoeba species. And so you'll see some of those in here. Like here's a good example where you can see multiple nuclei present. Going to confirm entamoeba. Just like last time, I forgot to save the trichrome, and so it'll take me back to it. I already know my answer. I've already confirmed entamoeba. And so we're on to the next one. If you have a situation where there are no protozoans, then you would expect to, as I see here, that the trichrome is negative. There's nothing to see to confirm there. But now looking at our wet mount, as I move through my classes, interesting artifacts, but not blasto. Nothing in Giardia, nothing in the cyclo. More of those artifacts showed up in the entamoeba. Proceeding down my classes, not seeing anything. Nothing in the protozoans. Some interesting egg look structures here. Not sure which species, maybe hookworm, but when I get to my Strongy class, you can see that there is obvious sign of the Strongyloides worm. Now you'll notice that the head component of the worm is what's being identified by our AI because of the relative size to other organisms, but it is trivial to confirm them when looking at the overview image that these are definitely positive. Because that was all of the work that I'd assigned to myself, my assigned to me entity, it took me back to the work list so that if there was more work to do, I could assign it to myself. Otherwise, it's time to go to my list of reviews that were positive and pull those for manual reads. That concludes the demo. Thank you all.
Wonderful. Thank you for that, John. Really appreciate it. One of the things that you will have noticed as John was going through the reviews are the presence of false positives. And that's one of the aspects of the system. This is not a primary diagnostics device. It is meant to have a trained professional. And so we've tuned our system to not miss organisms. Now, recently, as we mentioned, ARUP, they completed a study for wet mount iodine where they analyzed 477 specimens and controlled for 26 parasite species. And the results of that showed 100% agreement across 20 of the species for positive presence or positive accuracy. And the remaining 6 species all exceeded the 90%, which corresponded to their KPIs for the study. In negative accuracy, we had 100% agreement across all 21 species and 99% agreement with the remaining 5 species. And this is important because, as I was going back to that previous comment, what our system is mainly tuned for is being accurate and not missing organisms. Because we know that there will be a trained screener looking at the interface and making those reads, our main priority is to not miss any. And there's even a feature within the software that when you hold down the E key, it will show you what are called exemplars. It'll show you examples of what in digital pathology you can expect to see for each of the organisms. So it's very handy either for training or continued education, or just when you're not that sure. And so in summary, the Techcyte system offers high sensitivity and specificity. It lowers labor costs because it takes your read time down to under 30 seconds. And that enables less neuromuscular and eye strain. It's got a positive impact on recruiting, training, and retention. It improves the efficiency of the laboratories and increases job satisfaction. It's easier to maintain competence with intermittent use. Now, in high volume labs, that's of course not the case, but there are labs that don't get that many samples in. And it enables greater consistency and remote consults. Now, I would like to touch on the consistency because that's one of the big advantages of AI. Because the humans have their advantages and the AI have theirs. And when you combine them, that's where we get the true power. It's less stress on the technologists. I mean, whether you want to face it or not, the AI doesn't have any, fatigue in the early mornings or the post-lunch slump, or they're just about to go on vacation and the AI doesn't get distracted. And so all of those things the AI does really well, but the human can make those calls that John pointed out that today we do need the operators for. And when I say we need the operators, there are some other solutions that offer, they just present the results. But we prefer to have higher sensitivity and specificity in our tool. Now, regulatory pathway. Trichrome's been validated and has been running hundreds of thousands of samples just at ARUP alone for years now, over 5 actually. And we have already completed our pre-sub for Trichrome FDA, and it's currently marked under CE for Trichrome, and we are currently doing our IVD-R certification for CE as we speak today. And it's of course available for an LDT in the US for research use only. And there we go. That is our Techcyte Fusion Parasitology wet mount iodine product in a nutshell. Jacob, I'll turn it over to you because I'm sure we've got some questions to field.
Troy, John, thank you very much. Yes, we've had a lot of questions. Some we'll probably need to follow up later due to time. First question, is there a path to FDA clearance? I think you just answered that one, Troy. We are headed down that path, but many customers have viewed this as an assistive tool only, right? This is not a primary diagnostic tool, as Troy mentioned. So the gold standard of microscopy for a positive confirmation remains. Many have viewed this as an assistive tool. Others have perhaps done their own laboratory developed tests, things like that. Eventually, though, a path to FDA, yes, but many have been interested in doing their own validation of some sort now. Next question was, is this viewer IMS integrated to Epic Beaker? And is the case synchronization bidirectional? Meaning, are the cases in sync whether you're working in Beaker or Techcyte? John, let me have you take that one. I'll say that we do have an open API, so we can integrate with any LIS, including Epic Beaker. We do have a bidirectional potential. John, anything you'd add on this question?
You pretty much covered it there, Jacob. It's a standard web REST interface to integrate with. We do have customers who are doing what I would call one way, where they pull the result from Techcyte, which is created by the act of uploading a scan with the barcode. But we do have customers who are doing bidirectional communication, where their lab system is pre-creating a test case, and then when an incoming scan with that barcode is automatically mapped to it. There's a lot more detail to that. We'd be happy to follow up with you.
Great. I'll have you stay on here. A couple more questions coming your way, I think, John. The work and analysis is performed in the cloud. How do you record or document the work performed?
So in terms of recording the output, right? If there's LIS integration, it's pulled through the API. If there's no LIS integration, it is the users typically have Techcyte on one monitor or part of their monitor, and then the lab information system on the other, and they enter as they go. In terms of how long we retain imagery, there's options available on that. Our default is that we retain the images for 30 days. We're not meant to be the primary regulatory storage of the image data, but remember that all the positive slides are being manually reviewed, and so they would have their normal sample or slide retention policies. Typically a year, I think, is what most labs do for parasitology in the US.
Thank you. When toggling between the trichrome stain and the wet mount, would the system alert you, John, if after reviewing there was a discrepancy between the two?
The system does not alert you to a discrepancy because, according to the system, if either one is marked as positive, that test case is considered positive and should require the manual review. The other reason it does not do that is because there are some classes that are only available on one or the other. Like the Helminth worm egg classes, like they're only a wet mount item.
Helpful. Looks like there's one about photo references or exemplars. John, if you can maybe pull that up. I'm going to answer another question while you're doing that. Margaret asked, why has it not been approved by FDA, submitted in 2022? So we want to be clear, in this deck, we talked about a FDA pre-sub was submitted. So that's a Q sub. That is not a 510K submission. We got good feedback with that submission, but then the market, most of the market said, we are ready and hungry. And so Techcyte has devoted its resources to getting these laboratories going live with this solution under their own in-house or laboratory developed test. So Techcyte is eventually pursuing a 510K submission. There has not been one. We just have had some Q sub conversations with FDA. Great question, Margaret. Okay, John, that question was, does the program include any photos as references?
So built into our system, we have a reference library. And so, this is from one of my review interfaces. I'm hovering my mouse over, in this case, the Entamoeba species. I'm pressing and holding the E key, and that is bringing up a gallery of image looks for that organism on these scanners. And we have a library for every class. Because of how much I have the interface in, you only see some of the library. There's a lot more images in here than you can see from this overview. So hopefully that answers that question.
Yeah, it's been pretty cool with experienced technologists and with newer technologists, just having that digital look right in tool, even if they're fairly new at reading ONPs manually. There's been a lot of excitement around, okay, that's what it could look like digitally. We've got quite a library there. And then it looks like one last question we'll take time for, and then there are several others we'll follow up with you individually. We really appreciate the engagement today. Kelly asked, how many objects of interest are you typically looking at before you move on? That's a good question. I think a lot of our current customers would have different responses based on their level of familiarity. John, what would you say?
So when confirming positivity, once you see 2 or 3 images that are unmistakable or a collection that are probable, that's enough. You don't need to review all of the images that are displayed. So positivity reads are typically much faster than the negative reads, because negative, you have to check everything. But with positivity, once you see a couple of organisms on there, you're done. And you're on to the next sample because you've already marked it for manual read. It's a good idea to finish looking at all the other organisms, but typically, it's once you're manually reviewing it, you're going to find all the rest of those on the scope. Now, knowing that you're almost certainly, rather than looking at one of the 95% or 90% that are negative, now you're looking at something that has a better than 50-50 chance of being positive.
Yeah. Very helpful. Actually, I'm going to throw one more mulligan in. There was a question around some competitive solutions have more automated prep or have results on the most important species. Troy, you mentioned a little bit about this. What would you say when it comes to Techcyte's list of organisms and the product itself that's out there for sensitivity specificity? Would you add anything more?
I would just add that our solution today offers by far the most complete list of organisms, which makes it possible for laboratories just to perform these tests and not have to make specific outlier tests when asked for, but also in terms of our specificity and sensitivity, which are excellent, far above some of our other industry players who do have solutions that do this. However, our system, because of the way it's been tuned, but especially because of the expertise that went into training our data sets, we're extremely proud of the results we're able to get from this, which far bypass what some of the other more turnkey solutions. And there are others that do exist, but from the results that we have and the use that we've seen from both Mayo Clinic and ARUP and other large labs, our solution and the completeness of it allows them to have much more confidence in the reads that they make, especially as a negative screening tool, making sure that they're not missing organisms.
Thank you, John, Troy, very helpful. I learned some additional things myself today. A huge thank you to our attendees today and your level of engagement. We will follow up to respond to your questions. And one last shout out to ARUP Laboratories. ARUP, the study they performed, their collaboration with Techcyte in building out this wet mount iodine screening solution. We are delighted to partner with them and appreciate again everyone's engagement. This will be available on our website after today's session, and looking forward to joining you for our next episode, which is in only 12 days. Stay tuned for that one. Thanks again, all.
Bye-bye.